Hello everyone, welcome back to the channel. My name is Matthew Sanabria, and in this video we're going to talk about Terraform. Now, I know there are a lot of videos out there on the internet that cover Terraform already, but in my opinion, a lot of those videos introduce too many concepts at once. They'll introduce Terraform, but then they'll also introduce AWS, and it gets to be a little overwhelming for first-time Terraform users. So the goal of this video is to introduce Terraform to you in a way where you can be familiar with the concepts of Terraform and some of the patterns that you'll use when you work with it. So we'll start off by introducing what Terraform is, why you should use Terraform, and how to install Terraform. From there, we'll switch gears a little bit and we'll create a fictional company called Acme, and we'll see how Acme can use Terraform to manage their infrastructure. Now, we'll start out by having Acme manage their infrastructure manually in the infrastructure provider's web interface. Then we'll move over to codifying that infrastructure with Terraform. And then we'll see how Acme can use Terraform to scale that infrastructure in various ways. Now, in order to follow along, you'll need access to a few things. You'll need access to a Windows, Mac OS, or Linux machine. You'll also need to understand what virtual machines are and how to SSH to a virtual machine. And you'll also need access to the DigitalOcean cloud provider. Now, you can go to digitalocean.com in order to sign up for an account. And actually running through this video with me might cost you maybe a couple pennies, maybe a couple dollars, depending on how long it is you choose to follow along. But if you're worried about that, I have a referral link in the description below that you can use to get $100 credit for DigitalOcean for 60 days. You can go ahead and use that to sign up if you'd like. Well, let's get started. So what is Terraform? Well, the short answer is Terraform is a CLI tool written in Go that allows you to manage your infrastructure as code. But to really answer that, we're going to have to dive in a little bit deeper as to what infrastructure really is. Infrastructure can be defined as any resource that you or your company uses to read and write its data. A resource can be a GitHub repository, it can be a virtual machine, it can be a DNS record. All of those things are resources, they're infrastructure. And Terraform calls that infrastructure resources. So, infrastructure as code means to codify your infrastructure. So, what does that mean to codify something? Well, that means to create some sort of classification, some sort of standard, a process by which you can interact with those things. So, when we say codify your infrastructure, what we really mean is Terraform allows you to define a file, a blueprint of how you want your infrastructure to look. You're allowed to declare the state that you want your infrastructure to be in. Do you want 3 repositories and 1 virtual machine and 7 DNS records? Well, if you define that in your Terraform file, you can then run Terraform against that file, and Terraform will read that file. It'll interact with your infrastructure provider, whether that's GitHub or AWS or one of the other tens or hundreds. And Terraform is going to read that file and it's going to interact with your infrastructure provider, and it's going to actually make a decision on should it create the resource, should it read the resource, should it update the resource, or should it delete the resource. And those create, read, update, and delete operations are called CRUD operations. So Terraform will allow you to define that file, it'll read that file, and it'll make a decision on whether or not it should do something to real resources from your infrastructure provider. And as those resources change, as the requirements change, let's say you move from 7 DNS records to back to 4, Terraform will adjust and it'll make decisions based on the changes to your file, and it'll perform those operations against your infrastructure provider. So all in all, Terraform allows you to declaratively define your infrastructure, and it'll automatically interact with the API from your infrastructure provider to make that declaration reality. So why would you want to use Terraform? Well, if you've ever been responsible for creating infrastructure for an organization, then you might want to take a look at Terraform. Let's say I asked you to create 10 virtual machines. Now, creating those 10 virtual machines by hand is a pretty time consuming process. and it's actually very error prone. What if you made a typo on virtual machine 7? Or if you forgot to run a script on virtual machine number 4? How can you guarantee to me that all 10 of those virtual machines are created exactly the same way, exactly how they should be created? Well, you can't. But with something like Terraform, you can define all 10 of those virtual machines in the Terraform configuration file. You could run Terraform against that configuration file and be guaranteed that all 10 of those virtual machines were created exactly the same way. So it solves a data integrity problem by codifying your infrastructure. So you're getting exactly what you put in the configuration file. And additionally, if your job is to create a multi-tier application, maybe something that has a web server and a database server, it reduces the chance for errors there because you can tell Terraform to create a web server and a database server, and it can link those two together. Because you know if you're creating, let's say, project, some sort of project for your company, and that project needs a web server and database server, well, then you can define the Terraform configuration file for that project, and you can define the web server and the database server in that configuration file. And you can check it in right along with your application code. That way, developers and infrastructure engineers or whoever, they know, oh, the infrastructure for this application is here, defined in this Terraform file. Also, if you have a need to create more of a disposable environment, let's say you're doing some testing on pull requests and you need to spin up some infrastructure and then test against that infrastructure and spin it back down, Terraform's a great tool for that. You define your environment one time in the file, and then on every pull request, you create the environment, run your tests, spin the environment down. And that happens fast. So if I had to sum it up in a few words of why you want to use Terraform, you want to use it for data integrity to keep your infrastructure meeting the requirements and you know that it's not out of date and it's not incorrect. So for data integrity, you also want to use it for speed because it's pretty time consuming to create things by hand. And you also would probably want to use it for scale. It's painful process to create 10 VMs or 100 or 1,000 VMs. Well, with Terraform, that's a much easier process. So those are kind of the reasons why you might want to consider using Terraform for yourself and for your organization. So let's take a look on how to install Terraform. Well, first, you'll want to actually go to the terraform.io website. And from there, you should see some sort of a link to download Terraform CLI. If you click that, you'll be taken to a page where you can download Terraform for the various different platforms and operating systems. And you can click on the operating system that you are downloading for: Mac OS, Windows, or Linux. If you're downloading for Windows, you'll just run an installer. If you're downloading for Mac OS, it's just a binary that you can drop into somewhere in your path. And Linux, same thing. It's a binary that you can drop into your path. I'm running on Linux in this video, so I'm just going to go ahead and click Linux 64-bit. It's going to ask me to save the file. I can then open up the file and I can extract it, and I will get a Terraform binary. And now this Terraform binary is in my downloads folder. Well, I need this Terraform binary to be in my path in order for it to work. So if I open up a terminal and I move some windows around here, you can see that in my downloads folder, I have the Terraform binary. And I can run it from there too. If I just do downloads Terraform and then version, you'll see that that's Terraform 0.14.8. But if I just run Terraform, it says, hey, that command's not found. That's because it needs to be in your path. So after you download Terraform and extract it, you're going to need to move it into a location inside your path if you're on macOS and Linux. If you're running Windows, no need to worry about it. Once you run the installer, it'll actually add Terraform to your path. So you can just open up some sort of command prompt or terminal on Windows and run Terraform. But for me, I'm just going to move Terraform from my downloads folder into a location that I already have on path, which is in local bin. And then now I can just run Terraform and it knows where to get Terraform from. I can run Terraform version, and it says 0.14.8. So once you have that, once you have Terraform installed correctly and you're seeing similar output, you're pretty much good to go. I just wanted to note, in this video, I'm running Terraform 0.14.8. Now, this version is close enough to hopefully a 1.0 release that what you see here, if you're watching it at a later date, it should still apply to Terraform 0.15 or 1.0 or whatever it may be at the time that you're watching. And that's how you install Terraform. Now, I know we just finished installing Terraform, and you're probably really excited to start to use it. But before we do that, let's take a step back and let's see what managing infrastructure is like without Terraform. So for this, I'm going to pretend that I'm creating a fictional company called Acme, and I'm the only employee of that company, and I need to create some infrastructure so that I can begin to develop my Acme company. I'm going to need a virtual machine. I'm going to need a attached disk space, a firewall, and maybe a few other things. And I want this infrastructure to be hosted in a public cloud and be publicly accessible. And for that, I've chosen to use DigitalOcean as my cloud provider. So let's go ahead and navigate to DigitalOcean, and we'll go ahead and sign in. And we'll be taken to the web interface. Now, if you haven't created a DigitalOcean account, feel free to do so, log in, and you should see a web interface similar to this. And you'll have to create a default project. Mine is called Sudo Mateo, and it's my default project. Now, you'll have nothing in your DigitalOcean account if you're, created a fresh account. And I don't really have much in here either. You could ignore the spaces and the domains. Just pretend like they don't exist. But otherwise, aside from those two things, I don't have anything in this account. It's pretty fresh. So what do I want to do? I want to create a virtual machine that I can use to SSH into and develop my Acme company. So the very first thing I need to do is find out, well, what does DigitalOcean call virtual machines? Well, they call them droplets. So you'll see I can use this green create button to create a new droplet or a new virtual machine. If I hit that button, it'll bring me to the create droplets page. And here I'll be able to choose all the details that I want for my droplet. Very first thing it asks me is, what Linux distribution do you want to use for your droplet? Well, I'm going to use CentOS 8.3. And the next thing it'll ask me is, what plan do you want to use? The plan is going to be kind of the size of your virtual machine, right? How much RAM, how much CPU, all that stuff. Since I'm a very, very early startup, I don't have a lot of money, so I'm going to choose the lowest priced option to keep my costs down. So I'll choose basic, I'll choose the AMD CPU, and I'll choose the $6 a month plan because that's the cheapest one. And that'll give me 1 gigabyte of RAM and 1 AMD CPU with 25 gigabytes of disk space. Now notice, as I'm clicking these, if you notice the URL in the very top, things are changing. Do you see that it changes from 1 gigabyte to 2 gigabyte? Just take note of that for later because we'll need to come back to that. But choose the $6 a month plan. And now the next thing it wants to ask me is, do you need any extra storage for your virtual machine? Now let's assume I do, and I'm going to attach a 1 gigabyte block storage to my virtual machine. I'm going to manually format it myself. I don't need them to do it for me. That's fine. And that's going to simulate me needing some more application data. Now I need to figure out where I want to put this virtual machine in the world. Like, what data center do I want to put it in? Since I'm on the East Coast, I'm going to want to put this in the New York data center. So that way I have the lowest amount of latency when accessing this resource. So I'll choose New York 3. And you'll notice it automatically chose a default VPC network to place my virtual machine in. This you could pretty much ignore and just keep the default. That's perfectly fine. I don't need any additional options. I don't need IPv6. I don't need user data. I don't need monitoring. So I'll leave all of those unchecked. But for authentication, I do need to be able to connect to my virtual machine securely. So I don't want to use a password because this virtual machine's for development purposes and it's going to be out there on the public internet, for development and demonstration purposes. So I don't want to use a password. I want to use SSH keys. So if I click that, it says, hey, you need to add an SSH key because you don't have one. So I'll go ahead and say new SSH key. If you don't already have an SSH key, it gives you some guides here on how to generate one and add one and create one. So you can follow that if you need to, but I'm going to assume that you already know what SSH keys are and how to use them. So in this situation, I have my own SSH key already, which I'm going to fetch with my terminal. So I'm just going to cat that out, the public key. Go ahead and copy this over, paste it in here. I'm going to call it Acme SSH key. I'm going to add it. Now that that's added, it's going to ask me how many droplets do you want? How many virtual machines? And notice I can only have one droplet at a time with this configuration. That's fine. I only need one. And I'm going to call my virtual machine sudo Mateo droplet, because sudo Mateo is going to be my username for this company, and dash droplet just signifies that this is a droplet. Next, I want to add some tags. Tags allow me to identify my resources, for use later on. I want to give it two tags. One called Acme, because this is my Acme company, and one for my username, and it's going to be sudo Mateo. It's going to ask me what project you want to put it in. I'm going to leave it in my default project, and it's going to ask me if I want backups. I don't want backups, so I'll leave that unchecked. Then I can hit create droplet, and you'll see that's going to go off and create. And if I click on the droplets tab, or you can see it populate here, you'll see that my droplet is actually in the process of creating. This little blue bar here is signifying that it's starting up and it's creating. So I'm going to give that a few seconds to create. It should take anywhere between 15 to 45 seconds. You'll notice that it created my droplet and it assigned it a public IP address right here. So this is the public IP address I'll use to actually SSH into my droplet and use it. And you'll see here that it has some tags as Acme and sudo Mateo. The problem is this droplet is open to the entire world. So every port is open to the entire world on the internet. I'm going to need a firewall here to limit that access a little bit. It's still going to be open to the world, but only for SSH and for pings. Let's go to networking, firewalls, create a firewall. I'll call this one Acme firewall. It's going to accept all connections on SSH port 22, only for IPv4 rule IPs. It's going to connect all ICMP packets. It'll accept those only on IPv4 sources. And then I'm going to accept all ICMP, all TCP, and all UDP going outbound from my virtual machines of the world, only on IPv4 addresses, because we're not using IPv6 on this VM. We never check the box, so we don't need our rules to have IPv6. It says that it's going to ask me, hey, what droplets do you want to apply this firewall to? And this is where the tags come in handy. I can use tags here, so anything with the Acme tag will apply this firewall to. We'll hit create. You'll notice it's applied on one droplet, and there's 5 rules. And now I have my firewall created successfully, and it's limiting, the surface area of my virtual machine. Let's go back and grab that IP. Now that we have the IP address, I can SSH into that VM by doing SSH, and as the root user, I can select yes, and now I have SSH into that droplet. And I know I'm in that droplet because if I do IPA, you'll see that my IP address is the same that DigitalOcean was giving me. At this point, I have some infrastructure and I can begin developing my application and building up my Acme company. But we didn't use Terraform to manage this infrastructure. So if I needed to add more infrastructure, I have to point and click around. And again, it's very error prone, right? A lot of pointing and clicking to get to this point. So we'll see how to manage this with Terraform going forward. But before, to keep your costs down, let's destroy all the infrastructure we've created and start with a clean slate. And we'll use Terraform to bring up the same infrastructure that we've just created manually. But let's destroy everything first. So if you click the More tab, you can click Destroy. There's a Show Associated Resources tab. You can check that. It says, hey, this resource has a volume associated with it. Do you want to destroy it? Yes, I do. I want to destroy everything that's associated with this resource. Click Destroy. It'll ask you for the name of the droplet. Destroy that. So what did we create? We created an SSH key, a droplet, a volume, and a firewall. We just destroyed the droplet and the volume. Now we need to destroy the firewall. Click destroy on that. And the last thing we need to do is we need to destroy the SSH key. You can get that by going to settings and then the security tab. And you'll see there's an SSH key here. Click more, delete, and delete. And now we've deleted everything that we've created manually, and we have a clean slate again. And now we're ready to use Terraform to spin this infrastructure up. All right, now let's see how we can use Terraform to spin up that DigitalOcean infrastructure that we had created manually earlier. Well, the very first thing you might want to do is we know we're going to work with DigitalOcean. So let's search up Terraform DigitalOcean. There should be a link that links you to the registry.terraform.io page. And in here, you'll see a provider. Terraform, in order to use Terraform with a infrastructure provider, you'll need to find out which Terraform provider to use. Now, I'm not going to get too much into the details of this, but a Terraform provider is just a plugin that Terraform uses in order to interface with a given infrastructure provider. Since we're using DigitalOcean, we need to use Terraform's DigitalOcean provider in order to interface with DigitalOcean. Now, going to the registry, you can find a bunch of different providers. Here we can see that we're using the DigitalOcean provider, and you'll see a button on the right hand side that says use provider. Let's go ahead and click that, and let's just copy this code for now, and we're going to put it into a Terraform configuration file, which we're going to find out what that means in a second. So in order to use Terraform, so now I'm assuming you still have Terraform installed. So if you do Terraform version, you should still have your Terraform installed. In order to use Terraform with DigitalOcean, we need to create a Terraform configuration file. So I'm going to use this directory that I have here called Terraform, and that's just going to hold my Terraform configuration for this video. And you'll notice that I don't have anything in here. In order to use Terraform, we need to create a Terraform configuration file. Generally, by convention, the Terraform configuration file should be called main.tf. So main.tf. Let's edit a new file. Let's create a new file called main.tf in this directory. And all we're going to do is we're going to paste in that content that we copied from the web page. And now I'm going to talk about it first. Terraform files or Terraform configuration files are written in a language called HashiCorp Configuration Language, or HCL. Now, HCL, if we go to terraform.io/docs, I believe, we do language and then the syntax. This is the HCL syntax here. You'll see there's block types, block labels, etc., etc. And if you read this, you'll be able to find out more information about how HCL looks. But again, I'm going to just kind of give you the introduction on it. This HCL file it's very similar to JSON, but without all of the quotes and stuff, to be honest with you. But it takes these little blocks here, and these blocks, they do different things depending on what block it is. And some blocks can take a block label, and also the block labels do different things depending on what block you give them to. So here you can see we defined a block called Terraform, and then that has a nested block called required providers. And then that has a map called DigitalOcean equals, and source and version. So this is basically saying, hey, Terraform, I want to require the provider DigitalOcean, whose source is coming from DigitalOcean, and that is just from the public registry here in the URL, DigitalOcean. And the version of the provider I want to use is 2.6.0, which is the latest at the time of this video recording. But you can use other versions if you'd like. But I'm using the latest at the time of this video. And that's all that's telling Terraform, is configuring what provider do we want to use. Then down here, this block right here, this provider block, this is, if you're going to work with Terraform, you're most likely going to need a provider block because you need to tell Terraform, how do I authenticate to the provider? Now, if we log back into DigitalOcean, you'll see that we're logged in, right? We gave a username and password to log into DigitalOcean. We've already authenticated. So we were able to create the droplet and the firewall and the SSH key and all of that good stuff. But Terraform needs to quote unquote log in to the provider as well. It needs to log into DigitalOcean so it can manage resources. And the way it does that is we use this provider block here, and we're going to pass some configuration options inside the provider block in order for Terraform to interact with DigitalOcean. These are all of the arguments that this Terraform provider block takes, this DigitalOcean provider block. It takes a token, a spaces access ID, spaces secret key, API endpoint, and spaces endpoint. Out of all of those, only one of them is required, and that's the token. And you can read what it says. This is the DigitalOcean API token. This can be sourced with the following environment variables. So we need this token variable. All right, so let's do this. Token equals, and then a blank string. This is telling Terraform, hey, we're going to set this token variable to an empty string. But we need a real API token in here. So where do we get that? Well, if you go back to DigitalOcean and you click API in the bottom left, and you click tokens and keys, and you generate a new personal access token, you'll want to give it read and write access. Give it a name. I'll call it Terraform. Generate that token. This token here, you can copy the entire value, and you can place it right in here. Now, if you're already familiar with Terraform, you're going to say, Matt, this is bad. You're not supposed to put a raw token in here. You're absolutely right. We're going to see how to factor this out later. But for now, let's just add a to-do right above it. To-do, make, let's see, remove this from configuration so we don't leak secrets. Okay, so I'll just put a to-do here. But for now, I just wanted to show you that we're telling Terraform to use this API token when communicating with the DigitalOcean provider. Great. But now, how do we create something? Right? We want to be able to create resources. One of the resources that we created manually was the SSH key, if you'll remember. We copied the SSH public key and we pasted it into DigitalOcean and we created it. If we go to settings, security, you'll see that we don't have any SSH keys here. But let's tell Terraform to create one. So how do we do that? Well, if we go back to the documentation for the Terraform provider, you'll see here on the left-hand side, there's resources and data sources. Resources are things that Terraform should manage. Infrastructure, right? Things. Infrastructure that Terraform should manage. It should create it, it should update it, it should delete it. Data sources are infrastructure that Terraform doesn't manage, but it can just read them. So it's like read-only data sources. It'll allow Terraform to reach out to the DigitalOcean provider or any provider and read information from it. That's useful in certain scenarios, which we'll cover one. Let's go to resources here. You'll notice there's a bunch of resources here that we can use. We can create DigitalOcean droplets and firewalls and such. But one of the resources that are listed here is DigitalOcean SSH key. If we click that, it says this resource allows you to create a DigitalOcean SSH key. Well, that's pretty awesome because that's exactly what we want to do here. We want to create the SSH key. So let's just copy this actual example here and we'll just paste it into our code. And now you'll see that this is a resource block now. So a resource block defines a resource that you want Terraform to manage. Which type of resource? Well, a DigitalOcean SSH key resource. So it's the block, the label, and then this last one out here where it says default, that's the name that you want to give it. But what name? It's just an identifier for Terraform to refer to that resource in the code. Since this is going to be my Acme SSH key, I'm going to call it Acme. So now when we want to refer to this, if I wanted to talk to you about this resource, I would say, hey, can you update the DigitalOcean, the Acme DigitalOcean SSH key in the code? And you'll say, oh, okay, Acme DigitalOcean SSH key. It's a way for you to refer to this. This is an identifier. This will serve as like a fully qualified identifier for you to identify a specific block in the Terraform configuration file. Great. Well, I want to give my SSH key a name. I'll call it Acme SSH key, and I need to tell it which public key to use. And for that, I'm going to give it the string. And I had that before by cat SSH, the public key. And then if I copy that key over, and if I put it in here, now I've just told Terraform, hey, I want you to create a DigitalOcean SSH key called Acme SSH key, and the value of the SSH key should be that raw public key. So at this point in time, we have enough code to tell Terraform to do something. So let's save and quit the file. And now we have a main.tf file here with some valid Terraform configuration code in it. The next thing we need to do is we need to run the Terraform CLI command to do something with this. And you'll see this, there's some main commands here that you could run. And there's one called init, validate, plan, apply, destroy. Well, init sounds like something we need to do. And that's right, that's what we need to do. Since we now have a valid configuration, we need to initialize the configuration so we can begin working with it. So let's run Terraform init, and notice what it's doing. It's initializing the backend, which we'll cover that a very little bit in this video. It's a little bit out of scope. It's initializing the providers that we've wanted, because we've defined these in the actual code. So it says, hey, I found that you want DigitalOcean version 2.6, and it'll reach out to the registry to download that provider binary. And it'll give you some information here, and it says, hey, you've been successfully Terraform has been successfully initialized. You might want to try running Terraform plan to see any changes that Terraform wants to do. And we're going to do that. But first, I just wanted to show you the directory structure now. If you look at ls-la, you'll notice that a .terraform directory was created and a .terraform lock HCL was created. The lock we're going to ignore. It's just a lock file that specifies the versions that we were downloading. Not a big deal. In the .terraform directory, if I run tree -a, you'll see that the .terraform directory has the downloaded providers that we're using, namespaced out to, a fully qualified namespace. And notice it reached out and it downloaded this binary. Now we're able to start communicating with DigitalOcean. Okay, great. Let's do what it says and let's run Terraform plan. Terraform plan will read your configuration file. In this case, it's main.tf for us. And it's going to read that file and it's going to determine what actions need to be taken in order to make that configuration file be reality. And in this case, Terraform said, hey, in your configuration file, I saw that you have a DigitalOcean SSH key resource called Acme. I saw that you have that defined in your resource, and it notices that no such resource existed so far. And Terraform's like, hey, do you want me to create this resource for you? Notice it says this will be created, and it tells you what is actually going to create. It's going to create an SSH key, or it's going to create a DigitalOcean SSH key, the Acme one, whose name is going to be Acme SSH key, whose public key is going to be this. And these other two attributes, where do they come from? Because we didn't define them. Well, if you look at the documentation on the left, each resource takes arguments, which are things that you can provide as the user, but it also takes attributes. Or I'm sorry, it also returns attributes, which are things that are known once the actual resource has been created. So in this plan, it's going to say, hey, I want to add one resource, change 0, and destroy 0. And if you want to actually apply this, you can run Terraform apply. When you run Terraform apply, like we'll do now, Terraform will first run a plan, and then it'll prompt you, do you want to do these things that I'm saying that I want to do? So here, like I said, Terraform wants to create this SSH key. Do you want Terraform to reach out to DigitalOcean and create this SSH key for you? Well, yes, I do. So YES spells yes, hit enter, and you'll notice it says it was creating the SSH key, it created it, and it's done. So if we log into DigitalOcean now and go to settings SSH keys and refresh this page, you'll now see that we have an SSH key called Acme SSH key, and it gives you the fingerprint. It's not going to show you the public key because DigitalOcean doesn't show it to you. But now this was created. It reached out, and Terraform actually created this. So if we run now Terraform plan again, notice Terraform says, hey, I have nothing to do now because that SSH key exists. How does Terraform know that the SSH key exists? Well, you might be thinking like, oh, it's reaching out to DigitalOcean, it's checking. Not necessarily. You'll notice a new file has been created after we ran Terraform apply, and it's called terraform.tfstate. Terraform keeps track of all of the infrastructure that it's managing in what's called a state file. Those state files can be stored in different backends. In our case, we're using the local backend, which is why it created a local file. Let's see what's inside of it. You'll see it's a JSON file that has a bunch of different attributes here, but Terraform manages this file by itself. You should not manually edit this file unless you really know what you're doing. After Terraform created this SSH key, it wrote to the state file and it made a note like, I created this SSH key, and it made a note for it. Now, the next time Terraform runs, it consults the state file and it says, hey, what do I already know about? What do I already create? And it finds this SSH key definition in the state file and it says, oh, I created an SSH key called Acme with these parameters. And since that nothing changed for this parameter, Terraform's like, oh, I don't have to do anything, no changes. Let's force a change though. Let's go back into the main.tf. Let's update the Acme SSH key, and we're going to call it Acme SSH key -new. We're just going to change the name. We'll save and quit, and we will run Terraform plan. Notice what happened here. Terraform detected that the configuration file changed. We added the -new to the name, and notice what Terraform wants to do. It says, hey, I detected that your SSH key resource, you wanted to change it and add -new. So I'm going to update in place this SSH key Acme resource, and I'm just going to change the name from this to this. So notice it's not adding anything. It's not destroying anything. It's just changing one resource in place. If we want to proceed with that, we can run Terraform apply. YES spells yes. Hit enter. And now if we refresh the page on DigitalOcean side, you'll notice that the SSH key name now has -new at the end of it. If you want to change it back, update main.tf, remove the -new, save and quit, run Terraform apply. It wants to change it back. YES spells yes, apply it, refresh, and now it's back to the old name. And let's say we wanted to destroy things and we were done managing infrastructure and we wanted to destroy everything. Well, there's a Terraform destroy command. Terraform destroy will destroy all infrastructure that it manages. And in this case, Terraform only manages one piece of infrastructure, which is the SSH key. So when I run Terraform destroy, it's going to want to destroy only the SSH key because that's the only resource it manages, right? So it wants to destroy all resources. So if you're okay with destroying all resources, YES spells yes, it'll destroy it. If I refresh DigitalOcean now, you'll notice that the SSH key is no longer there. And if I wanted to re-add it, I would just run Terraform apply. YES spells yes, and now it's added back. And you will see it's back in here. Notice how fast that is. Everything's defined as code. It's codified. So now let's see how we can use this in order to create the rest of the infrastructure that we need, which is going to be the droplet or the virtual machine, the volume, and the firewall. So let's get that all codified in Terraform. Well, in order to get that codified in Terraform, we're going to need to look up some more documentation. The next thing that we'll probably want to create is the droplet itself. And you'll notice there's an example here. If we go to the droplet resource page, and there's all of these lovely arguments that we can pass to a DigitalOcean droplet resource. So let's edit the main.tf, and beneath the DigitalOcean SSH key, we will copy this. Nicer to copy code and edit it. And we're going to create a new DigitalOcean droplet, and we're going to call this one the Acme droplet. We're going to give it a name. The name's going to be sudo Mateo droplet. And we're going to give it an image. The image is going to be CentOS-8-x64. We need to tell it what region we want to add this in. We clicked NYC3 before. Now we need to give it a size. And where do we find that? Well, remember when I said we were creating a resource before and we were clicking CentOS and clicking basic and $6 a month and AMD, and this URL up here was changing? Well, notice there's a parameter here called size equals. We can just select the size we want here and grab this and use that as our actual size. Now there's a better way to do this, which I'll show you in a bit, but that's a kind of a cheap way to grab the size. And then we'll go through the rest of this. We have the name, the image, the region, the size. Do we want backups? We can do backups equals false. We don't want backups. Do we want monitoring? Monitoring equals false. Do we want IPv6? No, we don't, so we'll say false. The VPC UID, we don't need that because it's going to go into the default VPC. We don't need private networking. SSH keys. We actually do need SSH keys on this machine because we need to tell it which key to actually use to connect, but we're going to come back to that in a second. Tags. We do want to give it some tags. And notice, tag says it's a list of tags. Terraform has a concept of data types. So you'll notice these are strings. These are booleans. There's also numbers. There's lists. There's maps. There's, a couple of other types. But when something says it wants a list, it really means it wants it to be enclosed in square brackets. So tags are a list of strings. So we'll do Acme and sudo Mateo, which is what we had before. And now all we need is the SSH key. How do we tell Terraform what SSH key to use? We read the docs. It says this is a list of SSH IDs or fingerprints to enable in the format this one. If we want to retrieve this information, we need to use the API to retrieve them, but we don't want to use the API. Terraform is already creating the SSH key up here. There must be a way to tell Terraform to use this created SSH key in order to use it here in the droplet. Well, there is. And since this is a list, we need to put it in square brackets. But remember what I was telling you before about how this kind of makes up a full identifier of what you want? Well, Terraform understands that. So if you do something like this, DigitalOcean SSH key dot acme dot ID, you're referencing the ID field from the Acme named DigitalOcean SSH key. So you see here, DigitalOcean SSH key, Acme, and you'll say, but Matt, there's no ID field here. Well, if you remember from what I showed you earlier, each resource, once it's fully created, has attributes that get exported. And one of them is the ID. So now what I've done here is I told Terraform, create this SSH key and create this droplet. But since the droplet references the SSH key inside, that creates an implicit relationship between that droplet and that SSH key resource. Meaning, Terraform needs to create this SSH key before it can even create the droplet. But since our SSH key is already created, in this case, we're just going to be able to create the droplet directly. So let's see. Let's write and quit the file. Let's run Terraform plan. You'll notice Terraform says, hey, I want to create this entire droplet here. And notice backups are set to false. image is set to this, IP set to that, yada, yada, yada. All the things that we've defined, Terraform knows about. But there are certain things, like the IPv4 address, that Terraform won't know until after the resource is really created. Notice the SSH key, it got the ID of it. The tags are all populated. So we're defining our infrastructure here as code. If I'm okay with this, I can run Terraform apply. YES spells yes. Now Terraform's actually reaching out to DigitalOcean and creating this droplet. So if I click the droplets tab, you'll see that it is actually creating this resource for me. And I didn't have to do anything except for define it in the code. And now you'll notice Terraform says that's done and it has been created. But how do I know what the IP address is? I don't want to have to log into the actual web interface to find the IP address. Well, let's introduce something else. There's a concept in Terraform called outputs. So if we do output, and then I'll do IPs, or actually I'm just going to call this info. Terraform has a concept called outputs. And what outputs is once Terraform's finishing applying something, it'll output certain information to the screen for you to use. Output takes one argument called value, and the value that we want to output is DigitalOcean droplet.acme.ipv4_address. And again, you might be asking yourself, hey Matt, how do you know the DigitalOcean droplet called Acme has an IPv4 address attribute? Well, by reading the documentation, I noticed that it takes all of these arguments, but at the very bottom, it has all these attributes that get exported. One such attribute is the IPv4 address. I can access it by resource type, resource identifier, resource type, resource name, attribute. So now, if I write and quit this and run Terraform apply, YES spells yes, you'll notice at the bottom, it gives me an output. And now I know this is my SSH, this is my IP address that I can use to SSH into this instance. But we're still missing a few things, right? We're missing the volume and we're missing the firewall. So let's go ahead and create those as well. So let's go ahead and create the volume first. So we'll edit the main.tf again. And after the resource, we're going to want to add a new resource. We're going to add DigitalOcean volume because we see it here in the documentation. And you can see the example here of what volume does. Let's create this new volume. Let's copy the example and we'll edit it as fit. We'll create a new volume. We'll call it Acme. The name is going to be sudomateo-volume. And I want to put that as the first argument. The description I like to be the second argument. And we'll just say for this description is volume for sudo Mateo droplet. The region should be the same region as your virtual machine or your droplet. So NYC3. The size is in gigabytes. So we just want a size of 1 gigabyte. And we don't actually need an initial file system type. So I'm going to get rid of that. And the only other thing we might want to add is maybe some tags, but we don't even need that as well. But let's add it just for good measure. Tags equals, and then we'll call this one Acme, and again, sudo Mateo. Same tags as my actual droplet. And now I've defined a DigitalOcean volume that will be created, 1 gigabyte. How do I link it to my virtual machine? How do I tell this volume to be attached to this virtual machine? Well, there's a DigitalOcean volume attachment resource. And you'll see here that all it does is accepts a droplet ID and a volume ID, and it links them together. If I copy the example, I can do this. Call the volume attachment Acme. And I can give it DigitalOcean droplet Acme ID and DigitalOcean volume Acme ID. These are just the two identifiers to my droplet into my volume. And that's how Terraform will be able to link those two together. Let's try it. Let's run Terraform plan. It's going to want to create a volume, and it's going to want to create a volume attachment. If we run Terraform apply, you'll see that in the DigitalOcean panel, it is creating this volume, and it's attaching to the droplet. And that's done. And now the last thing we need is just the firewall. So if we go back to the documentation and we look at DigitalOcean firewall, you'll see that there's this big example here. Now we can copy the whole example if we want, but I don't really need all of it. I just kind of need a few rules, but I'll copy it all anyway, and we'll edit it as necessary. So right above the output again, add a new resource. We'll paste it in. This is going to be DigitalOcean firewall. We're going to call it Acme because we want to identify our resources. We're going to give the firewall a name called Acme firewall. For the droplet IDs, we're actually not going to use droplet IDs. Instead, we're going to use tags like we did in the actual UI. So the tags that this firewall should apply to are any droplet with the Acme tag. Now we need to give it a bunch of rules. One rule is we want to allow SSH. So we want to allow SSH from every IPv4 address. So we can do an inbound rule for TCP port 22 from all IPv4 addresses. And then we want probably, I'm going to get rid of all of these other inbound rules because we don't need them. We probably want a second inbound rule. And we want ICMP. So if we look at the documentation, it says protocol can be either TCP, UDP, or ICMP. Well, since we want ICMP, we'll just do ICMP. And then you'll notice it says for port range, you can specify any port you want. 1 to 633, all of that. The port range is only required when the protocol is TCP or UDP. And since we're ICMP here, we can get rid of the port range. And now the source address will be the same. And now we have inbound rules for SSH on port 22 and ICMP outbound to the world. And we're going to want to do the same thing for the outbound rules. We're going to want to create the outbound rule for ICMP. I'm going to put it up here though. And we want it to go only for IPv4 addresses. So we'll delete that. And that's done. And then we want to create an outbound rule for all TCP. So from port 1 to port 65535. And only for the destination addresses, everything IPv4. And then the same thing for UDP. Let me take that. And I like to keep these a little tighter, the blocks, because I don't want to have too much vertical space. I'll change this to UDP. And now we've defined a DigitalOcean firewall called Acme, whose actual name in DigitalOcean will be Acme Firewall. Any droplet with the tag Acme will be added to this firewall, and here are all the rules that this firewall will have. Now if I save and quit, run Terraform plan, it's going to want to create this firewall for me. I could run Terraform apply, and then YES spells yes. Go back to DigitalOcean, go to networking, go to firewalls, and boom, that firewall is there, connected to my one droplet with the 5 rules. At this point, we have created all the infrastructure necessary, and we've matched what we created manually before. But now that we've done it via Terraform, it's codified. This main.tf is all you need in order to repeat this infrastructure again and again and again. And before we move on, I just want to destroy this infrastructure. Terraform destroy. Yes. And now it's going to destroy all of the infrastructure that I've created. Notice how the firewall disappeared. Notice how the droplet is about to go down as well. Or let's look at the volume first. Notice how the volume is now gone. And notice how the droplet is going to start destroying momentarily. If we look at the page, this should start disappearing in the next 10 to 15 seconds. If we refresh, it's probably gone. Yep. So now my SSH key, my droplet, my volume, my firewall, all destroyed. And I'm not spending any money with my cloud provider because all of those resources have been destroyed. Now, there's more that I want to show you about the actual cleaning up this Terraform a bit. So we have this to do up here. So we'll take a look at that. And we'll take a look at kind of cleaning up this Terraform code a little bit. A lot of things are statically defined here. So we might want to start pulling those out into different variables and such. And we haven't discussed data sources yet. So we might want to introduce one of those. So let's go ahead and clean up this Terraform file a little bit and start to make things a little bit more flexible, I would say, in terms of variables and such. So one of the very first things I'd like to do is notice how we're defining the region everywhere, and the region needs to match across a lot of these different resources. So we're going to want to create a variable. Now, a variable block it declares a variable named this name right here. So I'm going to give this variable a name called region. And I'm going to give it a description so we know what this is. And this will be the region that resources are created in. Every variable, like I said before, Terraform is aware of types, of data types. So this variable needs a type. And the type is going to be string because these are strings down here. NYC3, NYC3, these are strings. Every variable can also have a default, which means a default variable means the variable is not required, because if you don't pass this variable to Terraform, it'll just use the default and it'll be fine. So now that we have a variable defined here with a default, we can go ahead and update the region to use that variable. Now, if you see down here, if we want to use attributes from other resources, we use this syntax: resource type, resource name, and then the attribute. But for variables, all we need is var dot and then the variable name. And then same thing for down here, var dot variable name. Now, anywhere this is located, it'll pull the value from this variable declaration. And since this has a default, we don't need to provide it when we run Terraform plan and Terraform apply. So if I save and quit and run Terraform plan, you'll notice no errors. It still knows to put things in NYC3, but it's just coming from a variable. And if I did want it to override it, I can do var. If I do -- help, you'll see that there's a var option. And I can do something like this: -var and then region equals, I believe it's SFO3. And that's, now you'll notice it's trying to place them in the San Francisco region. So it allows you to be a little bit more flexible with your code. I'm going to leave the default, but I just want to show you, what a variable looks like. Let's create a new variable. We still have this outstanding to do here. So let's take care of that. We'll create a new variable and we'll call it DO token. And it is going to have a description saying the DigitalOcean API token to use. Its type is going to be a string as well. And it's not going to have a default because we want the user to provide this. So let's copy this value here. Let's remove this. And we can remove this whole thing and do var.do token. And now if we try to run Terraform plan again, you'll notice it's going to prompt you for the DigitalOcean API token to use. If I paste it in here, it'll go through. But you don't want to have to type that every single time. So you have a few options here. One of the options is to make a terraform.tf vars file. And inside, you can give the variable a value. So do token equals this. And now you'll have a new file here called terraform.tf vars. And now that file wouldn't normally be committed to source control. It'll be overridden at the runtime. But now you'll notice if I do Terraform plan, it doesn't prompt me for a variable anymore because it read it from the terraform.tf-vars file. And that's a little bit better because it takes my API token out of my actual configuration, and it's a little bit safer. There's other ways you can do it too. You can just, if we go back to the DigitalOcean provider, we could have just exported one of these other environment variables, and that's a lot safer in my opinion, and that's what I tend to do. But it could be a little annoying for Windows users because exporting an environment variable on Windows is a little bit annoying. So I'm not going to cover it in this video, but I just wanted to mention it, and that's my preferred method. But for this video, we'll just keep it in terraform.tf-vars and just make sure you don't commit this to your source control repository. You might want to add it to like a git ignore file or something. So that's one way we can add variables to make things a little bit more flexible. What about this size? We only knew what this size was because we went to the DigitalOcean web interface and we clicked around and watched as the URL up here changed a bit, right? As we were selecting our sizes, we saw that this was changing. So we got lucky there. But you don't always get lucky. And what if we didn't know the size? What if we had to have Terraform find the size for us? Well, that's a good use for a data source. And let's see if there's any data source that would work for our situation here. Well, there's one called DigitalOcean sizes. And you'll notice here, this has an example of how to use it. But a data source, all it does is it doesn't create any resources. It just reaches out to the provider and reads information about a resource. Let's see how we can use this to get the same AMD image size that we've been using. So I'll go ahead and grab this example so we can start with that. I'm going to put it right beneath the provider. I'm going to call it DigitalOcean sizes, and I'm going to call it Acme. And you'll notice it has a bunch of these little blocks. And if you read the documentation, it tells you what it does. It has a filter block and a sort block. The filter block can take these things. The sort block can take these things. And all this allows us to do is we can filter the image sizes based on some of these values. So this says, give me an image that has 1 vCPU. But I also know I want 1 gig of memory. So I'm going to do memory. And DigitalOcean expresses its memory in megabytes. So we're going to do 1024. I also know that I want the region to match. So I'll do var.region here. So whatever region gets passed in the variable is the region we filter on. And then we also want to do another one. And we're going to do, the key is going to be slug. The values here is going to be AMD. And we're going to use this match by field here. And you'll notice one of exact, RE, or substring. This allows us to perform a match depending on what type of behavior you want. And what this basically says is, give me all image sizes that have 1 vCPU, 1 gig of RAM, inside the region that we specify, and whose slug contains the string AMD. And once you get those, sort them by the price increasing order. So give me the cheapest VM sizes first. And I know that's a lot to digest, but all this is doing is it's reaching out to the API on our behalf and it's getting information for us to use. So now we don't need to remember the size slug name. We have it automatically. And that allows us to take this size and change it to something like this. Data dot DigitalOcean sizes dot Acme dot sizes, because you'll notice that this exports a few different things. One of them is called sizes. This documentation is a little out of date. This should say sizes. And sizes is a list. We want the first item in the list, and we want the slug from it. And that is a lot to kind of swallow there, but similar concept. Remember how we did var dot variable name? Same thing. Data dot data source name, data source identifier, and then the attribute. But this is a nested attribute. Sizes is a list. We want the first item from that list. Inside of it is an attribute called slug. Now, if we run Terraform plan again, no change. It still knows that the size is the same size as before, but this time it's retrieving it from DigitalOcean itself instead of us manually defining it in the code file. And that's how you can use a data source. And now this code actually looks a lot better than what we had before because we're using variables in the places that it matters, and we're using a data source, and it shows all of the things you can use at Terraform. We have the Terraform block, provider block, a variable block, a resource block, a data source block, and at the very end, an output block. And these are all the things you can use in Terraform, with the exception of we're missing modules, but we're not going to cover modules in this video. So this really shows you the power of Terraform and what it can do. Let's apply this and watch it all come up live. Yes spells yes. We go back to the actual DigitalOcean page and click on droplets. You'll see my droplets coming up. It's still using the AMD CPU. The volumes are still getting created. Notice how it's created but not attached yet because it can't attach until the virtual machine is created. The firewall was created. The SSH key was created. All of those things were created. All because we defined them in one infrastructure file. And the cool part about this is now that we have this codified in a file, if someone were to go into DigitalOcean and do something malicious, like let's say deleting my SSH key, delete. If we were to rerun Terraform again, Terraform's going to detect that. It's going to say, hey, I had an SSH key here before. See? It's going to recreate it. But since the SSH key was deleted, notice this has to change now because that SSH key with this ID, that was deleted. Terraform's going to create a new one and it's going to associate it with the droplet, but it's going to have to update the droplet in place to do that. And that's fine. So we'll say yes. It created the SSH key. It associated with my droplet. And now we're back to normal. And this allows us to recover from some errors pretty easily. We don't have to remember like, oh, what SSH key was it? Like, oh, where was it? Nope. Terraform kept track of all of that for us. And now that all that's been created, we will go ahead and destroy it. Yes spells yes. And now we're destroying all the infrastructure that Terraform is managing. The SSH key, the droplet, the firewall, the volumes, all of that stuff. And Terraform's going to destroy it all, and it's going to report back that everything was destroyed. And then we're not spending any money with our cloud provider there because all the infrastructure has been destroyed. I'll just wait another couple of seconds for this destroyed to complete. The droplet usually takes the longest because, it's the most resource intense thing. All that's been destroyed. And you'll notice if we cat out the Terraform TF state file, there's nothing in it because it's been destroyed. And now we are back to square one with no infrastructure, but we've codified it via Terraform, so now we can create infrastructure at will. Next, we're going to look at how to scale the infrastructure using different methods. Now that we've codified our infrastructure, let's see how we can scale that infrastructure up with Terraform. We're going to cover just a couple different approaches here. The scenario is, let's say the Acme company is growing and I needed to hire 2 more developers to work on the application with me. Well, those 2 developers, they need their own virtual machines as well. So let's see how we would go about creating those in Terraform. So we have our main.tf and everything is actually defined in here, and that was fine for my virtual machine, my sudo Mateo virtual machine. But what if we wanted to hire more engineers? Well, let's create a new variable and we're going to call it engineers. And this variable is going to be, give it a description, a list of engineers to create resources for. Resources for. The type of variable is going to be a list, and we're going to give it a default so we don't have to define anything. And the default is going to be a list of strings. So one of the strings is going to be me, Pseudo Mateo. And that's going to represent my username at this company. Let's say I wanted to hire more employees. And since I'm a startup and I don't have a lot of money, I'm going to hire my doggies because they will work for cheap. And they do pretty good work actually. So I'm going to hire one of my employees, going to be Ava, and the other one's going to be Freddie. Okay. And let's actually switch them around. Let's put Freddie there and put Ava at the back. Great. So now we have 3 engineers. How do we tell Terraform to like loop over those kind of and create infrastructure for all 3 of those engineers, myself, Freddie, and Ava? Well, if you look at the documentation online, or if you kind of just searching around online, you might find a keyword called count. And you'd be correct, and that's one of the ways we can do it, and we'll show that way at first. We need to create multiple resources for these 3 different engineers. But not everything needs to be created, multiple times. For example, the SSH key, we don't need 3 SSH keys here just because we have 3 engineers. We just need one. This is going to be our Acme SSH key. It's going to be the default one that we use for like admin purposes. So no reason to create 3 of those. How about droplets? Do we need to create 3 droplets? Well, yeah, each engineer needs their own droplets. So we're going to do count here, and I'm going to do count 0 for now to hold a place. What about volumes? Do we need to get 3 volumes? Well, yeah, because each droplet needs a volume, and since we're creating multiple droplets, we'll need multiple volumes. I'll put a question mark there so we can come back to it. Well, what about volume attachments? Again, same thing. If we're creating multiple volumes and multiple droplets, we'll need multiple volume attachments. Okay, what about firewalls? Do we need multiple firewalls? No, not really. We don't need multiple firewalls because they're all going to be attached to the same firewall. So these are the 3 resources that we need to create multiple versions of, multiple instances of. Well, how many? Well, we know we need 3, right? We know that. We know we need 3 here. So we can change all of these to 3. Oh, and that will work. Oops, sorry about that. And that would work, but that's not correct. Because what if I hired a 4th engineer somewhere over here and, this could be Alice. What if I hired a 4th engineer here? What happens? Well, I'm giving a static count of 3 down there, so that's not going to work. There has to be a better way. Well, there is. And I want to show it to you before I discuss what it does. But there's functions in Terraform that you can call, built-in functions that you can find in the documentation, and they allow you to operate on some data. So for here, I can do length of var.engineers. Since var.engineers is a list, length of that variable will give us the length of the list. And that will dynamically adjust with our instances. Okay, so I'll update that. Oop, sorry. I'll update that. And that's done. Okay, and that's great. Now I'm going to get a variable size of resources each time. But there's still another problem. We're going to be creating 3 droplets, but they're all going to be called pseudo Mateo droplet. That's not good. And they're all going to have pseudo Mateo tags. That's also not good. And before we keep going forward, I want to take a look at what count really does. Count says take this resource and create this many instances of the resource. And that can pose a problem because certain attributes on certain resources can only be defined one time. For example, not in DigitalOcean's sake, but some some infrastructure providers you can only have one of a given name for a given resource. For example, let's talk about GitHub repositories. If you were to create a GitHub repository called, foo, you can't have another GitHub repository called foo. So if you did something like, GitHub repository count equals 7 and they were all called foo, well, you're going to get an error because GitHub's going to say, hey, foo already exists. So you have to think about that when you're using something like count. So count's going to say create 3 of these using this configuration, but we can't have them all named the same. So how do we modify the name for each count? Well, simple. We can do something like this. We can access, and now this $ syntax, $ brackets, I need this syntax because I'm inside of this string. I wouldn't need it otherwise. But I can access the var.engineers list, and I can give it count.index, and these are just built-in variables, this count.index. So since var.engineers is a list, I can access each nth element using native list syntax. Same thing I'm doing down here. But count.index is a special variable that holds the current index for the given count. So since this count is going to be the length of engineers, which is 3, this will hold 0, and then 1, and then 2. And it's going to access that list. So if I go back up, it'll give me sudo Mateo for index 0, Freddy for index 1, and Ava for index 2. Let's go back down to the bottom. So that solves that problem. And then for tags, I can do the same thing here. But this time, I don't need the quotes. I can just do var.engineers and then count.index, and that'll be fine. So I'm going to access the actual element of the list at that index. And then it's going to really be the same thing for down here. So I'm just going to copy this and then paste that. And then this is going to be volume. And this is going to be same thing. var.engineers and then count.index and then droplet. And then same thing down here. I'm just going to copy these tags because it makes sense. Okay. And now this attachment. This one we need a little bit of thinking on. So we're going to create 3 attachments, and it's going to attach this droplet to this volume, or vice versa, this volume to this droplet. Well, when you create a resource via count, right, you're able to access it using this same syntax that we have up here, because it's going to give you DigitalOcean droplet dot acme 0, 1, 2. So we're able to access it just like a list. So the only thing we have to change here is we have to do count.index and count.index. Now don't get too caught up if that syntax doesn't make sense to you. Once you read over the docs, it'll make more sense and really solidify the information. But it's going to create 3 of these volume attachments, and each time it iterates, it's going to attach this volume to this droplet. Well, which volume? It's going to attach volume 0 to droplet 0, volume 1 to droplet 1, volume 2 to droplet 2. And it's going to do that 3 times, 0, 1, 2. So now we have the ability to scale up to 3 different virtual machines for our employees that we've just hired. So let's see if we got it all correct, and we'll do Terraform plan. And we didn't. We messed one thing up. So it says on line 122 in output. Oh, right. Let's go down to 122. And notice, since we aren't using one virtual machine anymore and we have multiple ones, we'll need to actually do something like this. And we'll need to do this. Yep. So the star says, give me all IPv4 addresses for all of my instances. Now, if I do plan, it'll say, hey, we have 11 things to add here. Notice volume attachment 0, volume attachment 1, volume attachment 2, volume 2, volume 1, volume 0. And then same thing with the droplets. You're going to have droplets 0, 1, and 2. So let's go ahead and actually apply that. Yes spells yes. And you'll see that all of those droplets are getting created. One for me, one for Freddie, one for Ava. And they all get their own volumes, they all get their own tags. And in this scenario, well, everyone's pretty much happy in this scenario because they all have their own droplets. But I want to cover some of the actual drawbacks of this scenario. And I'm going to cover that next. So let's cover some of the drawbacks of this scenario. So all three of those engineers got their own droplet, their own volume, and volume attachment. And that's fine. But let's say I wanted to get rid of an employee. Let's say Freddie's not, pulling his weight anymore, and he just, is not doing his thing, and I need to get rid of him and send him back to, sleeping on the couch all day. Well, I would just remove Freddie from this list, and then I should be able to run a Terraform plan again and see what's going to happen. But if we run the Terraform plan, you'll notice it wants to do a lot of things. It wants to add 2 resources, change 1, and destroy 5 others. But I just want to destroy the 3 resources that Freddie's associated with: the droplet, the volume, and the volume attachment. Why is it trying to do all of this stuff? Let's scroll up and see what it wants to do. Well, it wants to take Freddie's droplet and rename it to Ava's droplet. It wants to destroy Ava's droplet. It wants to recreate Freddie's volume as Ava's volume. It wants to destroy Ava's volume, and it wants to recreate the attachments for the volumes. That's not what I wanted. I just want to destroy Freddie's resources. So what's going on here? Well, in order to understand what's happening, you have to see it in the code. Well, this is a list, right? And this list has 3 elements in it, and they're indexed at index 0, index 1, and index 2. And that's fine, right? Sudo Mateo's VM is, resource 0, Freddie's VM is resource 1, and Ava's VM is resource 2. And we see that when we do, Terraform plan this time. Like we see these resources, right? Here's droplet 0, that's Sudo Mateo's, droplet 1, that's Freddie's, droplet 2, that's Ava's. That's fine, so it's there. But when we delete Freddie from this list, Ava's index is going to have to change from 2 to 1. And that is what's causing all these problems. So the issue here is that using count is not really good for this method. You only really want to use count for things that you don't care about the individual resources. For example, if you're scaling up a web server from 3 nodes to 4 nodes, and you don't care, which node is which, or which node gets destroyed, or which node gets created, because they're all cattle, not pets, right? That's where count's really good for. But if you actually care about the individual resources, like in this case, we cared about, Freddie's resource versus Ava's resource, count's not the tool for you. And you can see, we can actually let this go and see what's going to happen. And we can do Terraform apply, let that refresh. And notice that if we go back to the droplets, Ava's IP address ends in .149, right? If we actually let this apply, what's going to happen? Ava's droplet's going to be destroyed completely. In fact, this actually might even error depending on what happens, but we'll see. You'll notice, go to volumes, the volume got recreated. It's going to try to attach. It's going to destroy Ava's droplet and Freddie's droplet. So notice Ava's droplet is completely gone, and Freddie's droplet was renamed to Ava's droplet. And notice this was Freddie's IP before 172. So Ava's VM got destroyed, and Freddy's VM got renamed to Ava's VM. They reattached the disk. So now the droplet that is called Ava droplet is really just Freddy's little droplet repurposed. This is a problem, and this is not something you want to do with count. So let's destroy everything. Since clearly this is, we've just messed up Ava's whole development flow because killed Ava's droplet and repurposed hers as Freddy's, and not really a good thing. So let's destroy everything and start from scratch, and we'll see how we can properly do this time. Let's refresh the page, and all the droplets are gone. This Terraform apply should be finishing any second, and there you go. Now we know that count is not the way here, so let's see a better alternative to using count. All right, so let's go back into the main.tf, and in this case, let's get rid of this. We're not going to actually do it this way anymore. And let's bring Freddy back into the fold and see how this would unfold if we architect this a little bit differently. Well, clearly lists aren't the way to go here. So let's change this from a list to a map. And we'll do a map of engineers, or map of usernames to engineers to create resources for. Now that we're changed to a map, we have to change these square brackets to braces, because that's map syntax. And maps take a key and a value. I'm just going to change these all to keys and values. Key and value. And I like to keep commas at the end of all my stuff because it's just nicer that way. So this is going to be a map from a username to an actual name. So I'm going to call this one Matthew Sanabria. I'm going to call this one Freddy. And I'm going to call this one Ava. Okay. So this will be my username and this will be my full name. Same thing with my pups. Okay. Now that I have a map, that allows us to do different things in terms of scaling out our resources. Instead of using count, we can use this for each. And for each allows us to loop over different resources. So we can do for each var.engineers. And for each allows us to do, for every item in a map, or for every element in a map, do something. And now, instead of using var.engineers here, we don't even need count index anymore. We don't need any of this anymore. Instead of doing what we're doing here, we can do each.key. And same thing down here. Each.key. The for each has a different syntax. Notice, remember how count had count index? Well, for each has each.key and each.value. Each.key will be each of these keys, and each.value will be each of these values in order, right? So the first time the for each is executed, it has this. This is the key. This is the value. The second time it's executed, it's this, and so forth. So now that we have that there, we change it to this for each statement. So I'm going to copy that and bring it down here and do the same thing. Each.key, each.key, and then same thing down here. And then each.key, and then update this last count down here from count to for each. And we don't need this anymore. We can do same thing. Each.key and each.key. Let's plan this and see what's happening here. Oh, I messed up one thing down here. I always forget about the output. Now that we're not using count anymore, we can't do this syntax here. So what we need to do is we need to change this to a literal for syntax. So for username engineer in var.engineers, give me the username. Actually, no, we'll just give me the engineer. And if I can actually find the equal sign, that would be great. There we go. Can't type today. And the IP address of each.key. I know this seems like a lot to look at, but basically what this is saying is for a key value in a map, give me back a map that has this as the key and this as the value. And the key is going to be the name, and the value is going to be the actual DigitalOcean droplet, but we can't use each.key here. We need to use username because that's the key in the map. So for the key and the value in this map, give me back the value and this attribute. And this, I'm going to come back to this because you're seeing it in a few places. You're seeing here each.key, you're seeing username. And I'm going to come back to this. I just want to show you what the plan looks like before anything. Notice this. This is actually pretty interesting. So if we scroll back up to the top, we see that it wants to create different droplets. But notice it's not 0, 1, and 2 anymore. This is Ava's droplet. This is Freddy's droplet. And this is Pseudo Mateo's droplet. We're no longer using a number-based list index. Instead, we're using a map. So each map has the keys. So now we're getting our 3 resources, but they're individually identified with a key. This is Ava's volume. This is Freddy's volume. This is Freddy's volume attachment. So let's apply this. Let it apply and we'll kind of chat about it. Notice this is a lot easier to read from an engineering perspective, right? This doesn't say 0, 1, 2 anymore. This says Freddy, Ava, and Pseudo Mateo. I know exactly which resource is being created now. Now, for each was a relatively new addition to Terraform. I think it landed in 0.12 or 0.13. I can't remember which. But it's been a lifesaver for cases like this. Now I can loop over complex data structures and dive into what I really need in terms of my use case. So let's refresh the droplets and we'll start seeing them come up. And notice Freddy's droplet's there, Ava's droplet's there, Pseudo Mateo's droplet's there, and I get this nice little info at the end, all printed out for me. Let's go back to the code. When you for each over something, you loop just like count, but for every iteration of the loop, you can get a key and you can get a value. That's all I'm doing here is I'm getting the key for each loop. When you need to access something, if you'll notice back in the outside the code, right? If I wanted to access a droplet, I can do DigitalOcean droplet .acme and then the actual key that it was created under. So if I go back to the attachment in the code, if I want to reference a droplet ID, I just do DigitalOcean droplet .acme .the key .id. And you'll notice here, since I'm for eaching in this loop, every time I go through a loop, for each is going to execute, and each key is going to be assigned the key from my engineer's variable up top. And since I'm for eaching over the same variable here, each key is going to be the same for each iteration. So that means when I create Pseudo Mateo's droplet, I can refer to Pseudo Mateo's volume and Pseudo Mateo's volume attachment. All of them line up because they're all based on the same key, which is Pseudo Mateo. That gives us some power here. And the power that it really gives us is this. I can still go ahead and do something like this and add Amanda, and make sure that she's there. Like I can do something like this, right? And then I can plan, and it's just going to want to add Amanda. Look, it's going to want to add 3 things. Amanda's droplet, Amanda's volume attachment. So that's not what I want to do, right? Let's go back. I want to fire Freddy, right? Freddy's not doing anything right for me, and I need to put him back, put him back on the couch and let him hang out all day. Now, I can delete Freddy. I can run the plan, and no longer do I have this weird, 5 to destroy, 1 or 2 to add, and 1 to change, or whatever it was. All I'm destroying is Freddy's infrastructure. And I can see that in the plan output. Freddy's droplet will be destroyed. Freddy's volume will be destroyed. Freddy's volume attachment will be destroyed. If I run this now and I apply it, I'm able to just target my destroy or my operations to that specific infrastructure. I'm no longer affecting Ava anymore because we're using for each. So it's different, right? Count is really good when you're dealing with cattle, not pets, right? When you're dealing with infrastructure that you don't have a preference for one or the other. And for each is really good when you need to create multiple things, but you need to be able to address just one at a time if you need to destroy something or update something. So they all have their use cases, but there are two different ways of scaling up infrastructure and scaling down infrastructure. And they both have their drawbacks. Count is super simple to use because it's just a number, right? Like you want 100 VMs, count 100 and you're done. But if you care about VM, in the case of 100 VMs, if you care about VM 76 over VM 72, you have a problem. Count's not for you. And I see a lot of people run into this situation when they're using Terraform. They use count and then they get frustrated when they go to destroy something or change something. They're like, why does it want to create, why does it want to destroy 96 resources? Well, you use count and you're trying to destroy resource number 56. So it wants to destroy 57 and up. So think about that when you're using Terraform to scale out your infrastructure. And now, again, I want to destroy everything before we go because I don't want to have you pay for things that you're not using. So go ahead and destroy all that infrastructure. And now if I refresh the page, you see the 2 droplets there after I destroyed Freddy. And then now Ava and Pseudo Mateo will be destroyed soon. Still on the volumes, and now it's destroying the droplets. So if I refresh again, it should probably be on its way out. Yep. And now everything's destroyed. And that's using for each. And again, different pros and cons. You need to decide what's best for your use case and allow you to do things in your best way. That's pretty much all I wanted to cover in this specific video. You've seen the patterns that we use. You can see that when you're writing Terraform configuration files, you do a lot of back and forth between the code and the docs, right? So if you're like if we're using the DigitalOcean provider, we're going to be bouncing back and forth between the provider documentation and looking at the different resources and data sources and the code. Bounce back and forth because you got to see what you want to use, right? So that's the pattern. Start the code file, look at the docs, make the code changes, iterate, and that's the kind of pattern you'll be looking. You'll be spending a lot of time reading the documentation. But this video introduced kind of the basic concepts of Terraform that you're going to find on a day-to-day, basis. All of the major blocks that are in the Terraform configuration files, some of the basic Terraform commands. It's also going to introduce like how to look at providers, docs, and whatnot. But before I call it, I wanted to show you kind of like what you might want to do as next steps. I would highly recommend to continue to play with Terraform and, whatever cloud provider that you may be running on or whatever you're using. Get hands-on keyboard, right? Practice. Get used to writing some Terraform configuration, planning, applying, destroying, all of that stuff. Get used to that flow. It's going to really speed up your infrastructure creation and it's going to allow you to understand how to interact with APIs. But I really recommend to everyone that they go in to terraform.io and they go to documentation, Terraform language, and they go to this Terraform language page. And anyone who's really serious about learning Terraform, I recommend them to read from the overview section. From the overview section all the way down to the state section. So read overview, read files and directories, read syntax, resources, data sources, providers, variables and outputs, modules, expressions, functions, settings, and state. Read all of these cover to cover. That'll really help solidify the knowledge. There's a lot of good information here that I don't even have the time to cover in a video. I mean, this video itself was already long enough, and I didn't even get to some of the things that I maybe should have. But read the documentation. It's going to help solidify the knowledge and really connect the dots. And get hands on keyboard. And if you need anything or if you want to ask any questions, feel free to leave a comment or contact me. And if you like this content and you want to see more of it, please like and subscribe to the video. I'm here. Leave some recommendations on content you'd like to see. And thank you for watching this video, and I will see you in the next one. Take care.